My name is Andreas Antonopoulos. I'll be talking to you about Bitcoin. First of all, let me ask a question. How many people in the audience have heard of Bitcoin? Very good. How many people in the audience have Bitcoin or have used Bitcoin? Yeah, very nice. Okay, if you don't have Bitcoin and if you've never used Bitcoin, I will be happy to give you some Bitcoin, not a Bitcoin, but a bit less than a Bitcoin, at the end of this presentation for free, because I think it's really important to try and experiment with Bitcoin. It's better than explaining Bitcoin. So please come and see me after the presentation if you'd like to try it. So I'll start with what is Bitcoin? It's not an easy topic. When you look at Bitcoin the first time, you think, okay, digital money. But Bitcoin is more than digital money. If a fax machine is digital media, then the internet is media as software. And Bitcoin is digital money no more than the fax machine is digital media. Bitcoin is software money. And there's a big difference between digital money and software money. Digital money is handled by a platform. Digital money is stateful. Digital money only exists in a session that is controlled by someone else. When you use digital money, you use it on behalf of Visa or MasterCard or Deutsche Bank. But Bitcoin is software money. Bitcoin is stateless. Bitcoin is not a platform, it's a protocol. And as a protocol, Bitcoin can be used everywhere, can be used by software, can be programmed, can be scripted. In my opinion, Bitcoin is the missing layer of the web. Interestingly enough, if you look at the early specification of the web, there's an HTTP code for payment that was never implemented. And the reason it was never implemented is because you can't make stateless digital money. You cannot have money that operates on any system as an open standard and an open platform if that money is controlled by banks. Because their system depends on a closed platform. It depends on having a session and state. And it is very controlled. Bitcoin is finally the implementation of money that can be used as an HTTP payment code on any platform, by any piece of software. And when you use Bitcoin, you can use it internationally, and you can use it without borders and without controls. This is a very new form of money. So what's really interesting about Bitcoin is that Bitcoin is validated by a consensus network. What that means is that when you have money as a protocol, its interpretation depends on a set of rules rather than a set of platforms. Its interpretation by these rules is independent of where you use it. When you write a Bitcoin transaction, that transaction stands independently of any session you may have and can be validated by any system that understands the Bitcoin protocol. These network rules allow anyone to validate a Bitcoin transaction without reference to any external system. This has some very important implications that are not immediately obvious. The first important implication of this is that until now, money has always been owned and controlled by people. In order to make a payment, you need a human. And that human may be in the form of a person, or it may be in the form of a corporation, but it must be owned by something that has personhood. Not so in Bitcoin. Bitcoin can be owned by software. Bitcoin can be owned by independent software agents, by apps and applets. So with Bitcoin, you can create machine-to-machine payments for the first time in history. Bitcoin also is the first network that brings together payments at any scale. Traditionally, payment networks are scale-specific, meaning that we have financial networks for small payments, and we have financial networks for big payments. You use a different financial network to buy a cup of coffee at Starbucks. Perhaps you use Visa or MasterCard. And you use a different financial network in order to pay the national debt to the central bank. And you might use SWIFT or something like that. You use a different financial network to make payments inside the country than you use to make payments across borders. This is exactly the same as was the state of the internet, as the state of content before the internet. So before the internet, we had networks for voice, networks for data, networks for images. We had networks for small amounts of data, and we had networks for large amounts of data, and none of these networks could talk to each other. And then came the internet, and we had one network for all types of content, and one network that you could use to send one image, and the same network that you could use to send Encyclopedia Britannica, or every image ever taken. So the internet created for content the first network that was scale-free and content-independent. And Bitcoin creates for money the first network that is scale-free, destination-independent, neutral. In fact, if you think about it, one of the hot topics on the internet that concerns programmers, but everyone else as well, is the concept of net neutrality. Net neutrality on the internet means that you can send information from any person to any person, and the network itself doesn't care about what the content is, and it doesn't care about what the origin or the destination is. It only cares about transmitting bytes from source to destination. Bitcoin is the first payment network that exhibits net neutrality. A Bitcoin transaction is transmitted regardless of who the source is, to any destination, regardless of the destination. And the transaction itself may contain a small amount, it may contain a large amount, it may refer to a currency or a stock or a bond. You may transmit ownership of a house or a car or a bicycle, and the network doesn't care. The network simply validates that the digital signatures are correct and that the source and destination can be exhibited or translated into the Bitcoin network. This means that for the first time, we have the ability to implement net neutrality in finance. Now, if you're not interested in money, you may think that Bitcoin is irrelevant because, after all, there's so many things you can do on the internet that don't involve money. But Bitcoin isn't just money. Bitcoin is the ability to create a trusted network for expressing value. And that value can come in many different types. You can think of Bitcoin as a network for allocating resources and transmitting promises. And if you think of it from that perspective, there are many things you can do in software that have never been done before. Bitcoin scales from the tiny to the enormous. I'll give you two examples. One of the early demonstrations of Bitcoin was from one of the well-known Bitcoin investors in 2011. And they were sitting with many of their investment friends around the table, and they said, "Let me demonstrate Bitcoin for you, because to demonstrate is better than to explain." And so 6 friends downloaded a Bitcoin wallet, and the first person said, "Okay, I will send you some Bitcoin, and then you send it to the person next to you, and then they send it to the person next to you, and we go around the table. Hot potato. You just take the Bitcoin and transmit it to the person next to you." So the first person transmits the Bitcoin, and the second person looks at their phone, and they've just received $250,000. And then, very quickly and with great anxiety, they transmit it to the next person, and the next person, and the next person. And 5 minutes later, it's returned to the original owner. And so at that moment, people realize that you've taken $250,000, transmitted it 6 times to 6 people who could be at opposite ends of the planet in a matter of minutes. and the total amount of transaction fees paid was less than $1. This kind of experience is simply impossible to do with traditional forms of money, and this type of experience shows the breadth and scale of what can be done with Bitcoin. From a programming perspective, however, it is even more interesting to look at the other end of the scale. A few months ago, a new application was launched called Streamium, which you can find on streamium.io. And Streamium is a platform for streaming video in exchange for Bitcoin micropayments. Essentially, it allows content creators to charge for live video streams in increments as small as every 200 milliseconds, with payments as small as 1 Satoshi, just 100 millionth of a Bitcoin. So in that scenario, you can take any service that is charged by the minute, and you can present this service and then charge in tiny, tiny increments for tiny amounts of Bitcoin, all without any prior arrangement, without any access to bank accounts, and directly between pieces of software. Imagine the possibility of self-driving cars paying each other small fees to overtake, or software agents collaborating on deployment of software and paying for services like storage and CPU and network bandwidth, using payments that are billed on a millisecond basis. Once you start understanding that Bitcoin can exist without context and can be used by software, the possibilities of applications are truly enormous. Now, Bitcoin creates this environment by relying on network consensus. In the Bitcoin environment, every transaction is broadcast to every participant in the network and is independently validated by every participant in the network. This validation is in itself stateless. You can validate the digital signatures on the Bitcoin transaction without any reference to any external authority. Each participant in the Bitcoin network can have a complete copy of the ledger and can verify that the Bitcoin has not been and cannot be falsified, it has not been spent, and that if that transaction is recorded on the Bitcoin network, that amount of Bitcoin will now have a new owner. And this validation can be done independently by each participant on the network. The Bitcoin network operates through these rules of consensus that are mathematically expressed and that are validated every 10 minutes as new transactions are recorded on the network. By engaging the rules of consensus, essentially the function of clearing happens in a completely decentralized, peer-to-peer fashion by all of the participants in the network. There is no account, there is no service, there is no central server in any of the system. In technical terms, Bitcoin resembles peer-to-peer networks such as BitTorrent or Tor. And it operates in this completely decentralized fashion in a way that ensures that as long as there are two nodes that are still speaking the Bitcoin protocol and engaging in the network, Bitcoin continues to exist. This independence from central banking and banking in general, this ability to exist outside of borders and outside of governments, makes Bitcoin the perfect money for the internet. It really brings money into the internet age by turning money into a form of software. But it's much more than that, because the rules of consensus are about transmitting trust and promise. And while currency is the first and most obvious application, it's just an app. The Bitcoin system as a whole can transmit promises about any form of asset and any form of ownership, either referring to an abstract token, such as currency, or to a very physical thing, such as transferring ownership in a home, a car, or a bicycle. you can trade physical objects by associating them with tokens. This has tremendous implications for crowdfunding, for ownership registration databases, for stock markets, and for many other things that are not about currency. Even for abstract concepts like loyalty or reputation, you can use now tokens that are, at the moment of their creation, fully global, unforgeable, interchangeable, and where anyone can transact them with anyone else in a flat, completely egalitarian network. But it goes even deeper than that, because a Bitcoin transaction is not the transfer of Bitcoin from one person to the other. A Bitcoin transaction is itself a piece of software. Each Bitcoin transaction contains within it a scripting language, and this scripting language allows you to verify ownership of the underlying asset. When I send Bitcoin from myself to someone else, what I'm saying is this Bitcoin can be redeemed, or this abstract token can be redeemed by anyone who can satisfy the conditions of this script. For those who are familiar with languages that are based on a stack, the Bitcoin scripting language is a stack-based language that is very similar to Forth. So the assignment of ownership happens by validating a script. Most of the scripts in Bitcoin define a relationship to a digital signature, which means that when I send money to someone else, what I am saying is this money belongs to whoever can produce a digital signature that matches this public key. That is the most common type of script. Pay to public key, or pay to public key hash, as is the case in Bitcoin. That type of script is the most common, but of course it's not the only type of script you can build. In fact, you can build multiple very complex scripts through reusing some of the 30 or so operands that exist in the language. And with those operands, you can do very complicated things. You can use hashes as identifiers, or you can use complex assignment of ownership. One of the exciting features in Bitcoin that was introduced in 2012 is the concept of multi-signature technology. With that, you can say this Bitcoin is payable if 2 of the 3 following public keys can produce digital signatures. That example is a 2 of 3 multi-signature. So imagine a scenario where you have a corporation, a small company, and that company has 3 managers, and you want to make sure that no manager can alone spend the Bitcoin. You can allocate the Bitcoin to a multi-signature address where at least 2 out of the 3 managers must sign. But because this script is very flexible, you can have multiple layers and complexity expressed within the script. For example, you could say, this Bitcoin is payable to, with signatures from 1 of 2 senior executives, or 3 of 5 middle managers and 1 of the executives, or 5 of 15 lower level managers and 3 of 5 middle manager executives. So now you're using compound statements with conditionals in order to evaluate the ownership of this money. As Bitcoin has evolved over the last 6 years, we're seeing new features being added into the scripting language that allow for the beginning of simple contracts. For example, one of the new features is the ability to postpone the processing of the transaction called lock time. This is very similar to writing a check where you change the date and you say this won't be processed until 2 weeks from now. Now, I have to explain myself because I come from the United States where we still use checks. And as I understand it, the banking system in Europe has progressed since 1970. And so a check is a piece of paper where you write over money to someone else and you can put whatever date you want in it. Imagine that. It's amazing technology. Now, with Bitcoin, what you can do is you can take a payment and say, this payment can only be spent in 30 days, or this payment can only be spent in 1 year. But then you can take that and you can combine it with other operands in the language and create complex constructs. So you can say, for example, this money can be spent now if one of the 2 signatures is available, or in 30 days if 2 of the 3 following signatures is available, or in 90 days if 5 of the 5 signatures is available. Using a construct like that, what you're doing is you're creating ownership in time that expands as time goes by. At any point in time, the first 2 signatories, participants, can sign and spend the Bitcoin. But the second group of participants can only sign after a certain period of time. Using a combination of multi-signature technology and future lock time, people have built complex bidirectional payment channels that allow for escrow and micropayments in time and many other things like that. Imagine, for example, using this technology in order to allow for sharing of Wi-Fi access, not on a 24-hour basis, but on a 30-second basis, and being able to charge as low as 1 cent or 0.1 cent for every 30 seconds of Wi-Fi access. And so you see, when you bring together the possibility of a scripting language in a software-based system that can be used entirely without context in a stateless, protocol-based verification system that is simultaneously uncensorable, global, and unforgeable, we have for the first time a uniquely software-based form of money. And this doesn't exist without historical context. The internet itself, and now Bitcoin, are showing us that society is moving from systems of organization based on hierarchies to systems of organization based on platforms that have interfaces, to finally systems of organization based on network protocols that have context everywhere. And so this move from hierarchies to platforms to protocols has already happened for content, entertainment, media, news, and personal communication. Until now in money, we had seen only the first move from hierarchies to platforms. A bank account with Deutsche Bank is based on a hierarchical organization and institutional money. PayPal was the first form of platform-based money where you have an API that allows you to access that money, but still it's locked within PayPal. It's controlled within that environment, and it only exists in the context of a PayPal account. And Bitcoin now is the 3rd generation, completely network-centric money, money based on a protocol, money that works globally without context and without restrictions. Thank you very much. I'd like to take answers from questions from the audience. I beg you to please speak in English if you can, or someone to helpfully translate for me. Any questions in the audience? We have a lot of time to answer questions, so please do ask. Yes, sir.
Thanks so much. So far, I would be interested in alternatives to Bitcoins. What's your take on those?
Alternatives to Bitcoin. This is a very interesting question. You can think of Bitcoin as 2 things. On the one hand, it's the first implementation of this design pattern. On the other hand, it shows us what this design pattern can do for many other systems of currency or ownership. And so there are now more than 1,000 other implementations that use the same design pattern to develop alternative currencies. These currencies may have different monetary policies. Some may be inflationary, some may be deflationary, some may implement redistribution of income or other forms of monetary characteristics. Other systems based on the design pattern have nothing to do with money. Some are specialized in registering facts and information in an immutable database that survives through time and is not controlled by anyone. So using the blockchain technology as a decentralized database through time. One specifically, which is very interesting, is Ethereum. And Ethereum is a Turing-complete blockchain-based system that allows you to express arbitrarily complex contracts using normal languages resembling Python or C or Lisp in order to encode these contracts, which are then enforced through the consensus mechanism on the network. We're beginning to see an explosion in research and innovation in this space, started by Bitcoin and taken on by many other systems that use the same design pattern. At a very fundamental level, we're going from a world of 194 monopoly-based national currencies into a world of potentially thousands of network-centric currencies that exist and are fully interchangeable on the internet. Thank you. Any other questions? Yes?
I heard some news that the Bitcoin system is going to be forked or split or something like that. Can you, for newbies like me, go a little bit into that, what that means?
Right. So, gentleman says, I heard some news that the Bitcoin network is going to be forked or split. Can you explain what that means? This is an interesting concept because on Bitcoin, forks happen all the time. A fork is a divergence in the hash-linked database called the blockchain, where there are two potential copies across the entire global distributed system, and these two copies have to be reconciled in time. Think of it similar to how a networking protocol may have two alternative routes to a specific destination, and then over a short period of time, you will have reconvergence of routing tables across a global network to reconcile between these two alternatives. Forks happen on a regular basis because it's part of the distributed consensus mechanism, and forks are usually resolved within 10 minutes. Any transactions that existed only in one fork are still valid, and they get re-queued for processing in the next block, so that for most users, the experience of a fork is completely invisible, which is why most people don't know that Bitcoin forks almost every day. What you're talking about is a specific type of fork that is due to a disagreement about how the protocol should be upgraded. One of the interesting things that's happening in Bitcoin is we're seeing a new model for open source development and governance. Because in all other open source projects, if you create a new version of the software, and that new version of the software is backwards incompatible, it doesn't matter because most people can make their own choice as to which version they use. But because Bitcoin requires real-time, network-centric convergence and consensus on the rules, if you create two incompatible pieces of software, essentially the users of Bitcoin and the miners in Bitcoin will have to vote on which version is the correct version. So by upgrading, they vote to use a new set of consensus rules. There's currently a debate going on in Bitcoin as to how to scale Bitcoin for a larger number of transactions. And in that debate, there are two opposing views, and eventually, probably by January of 2016, these will emerge as two software versions, and the consensus algorithm will have to choose between them. In the process of upgrading, the participants in the network will choose between one of these two upgrade paths, and the Bitcoin network will continue on only one of those paths effectively, where the majority of the users are and the majority of the economic activity is. If you own Bitcoin before, then after you own Bitcoin for a short period of time on both versions until it reconverges, and then you still own Bitcoin on the new version. So again, for many users, if this goes properly and there's no problems with it, there will be no notice that this has even occurred. There's a lot more drama and panic by those who don't quite understand how that would work with the idea that you could have a fork. But we've had forks before, and I am of the opinion that there's too much drama for not much problem. Any more questions? Yes.
I have a question. As far I'm also newly to this topic, but as far as I understand, the whole history of all transactions that ever have happened needs to be stored or needs to be gathered in order to make sure that future transactions can be done. Is that correct understanding?
It's almost the correct answer. So the question is, I understand that in order for transactions to be verified, the whole past, the history of every transaction that has ever happened must be consulted. That's not entirely true. There are ways to get around that, but basically in Bitcoin, every transaction is broadcast to everyone, and nodes may choose to keep a complete copy of every transaction that's ever happened. That's about 40 gigabytes of disk space right now. Many people in the Bitcoin space believe that this is not really a problem, simply because at Moore's law rate, a system that has 40 gig of disk today will cost the same as a system that has 40 petabytes of disk in 10 to 15 years. And therefore, the network can scale to absorb that quite comfortably. The other thing is that you can choose to do what's called pruning of the blockchain. So for example, if the Bitcoin mentioned in a transaction, let's say I transfer Bitcoin to you and we record in the transaction that you now own this Bitcoin. If you spend that Bitcoin that has now been spent doesn't need to be, the history of that Bitcoin doesn't need to be retained by everyone. What now needs to be retained is the new Bitcoin that you transferred to someone else. So any transaction that has already been spent can be pruned. There are also ways to run lightweight network nodes that can essentially construct a summarized chain of transactions with emphasis by pruning a tree. This is essentially a hash-based tree, pruning those branches that are relevant to their particular transactions and only keeping the ones that are relevant to the transactions they're interested in. So there are many very interesting scalability, optimization, compression, and performance problems, as well as solutions that are advancing the state of distributed systems very rapidly because of Bitcoin. Yes?
Outline some interesting attacks and how the protocol is protected against them.
Some interesting attacks.
Yes.
Well, so Bitcoin has now existed for 6 years. So far, we have not seen a successful attack against the system itself. And part of the reason for that is because of the nature of decentralization, there is not a single target to attack. Instead, all you can attack is the mathematical outcome of the consensus rules, and that requires such an enormous amount of computation, and that's where the security of the system as a whole comes from. Over time, we've seen a number of denial-of-service attacks, which are probably the most easy to implement against the Bitcoin network. And denial-of-service attacks have been less and less and less effective over time. So Bitcoin exhibits the same kind of anti-fragile characteristics that we see in decentralized networks. Just like on the internet, for example, the scale of a denial-of-service attack that was required to take down Google in 1999 was so low that, in fact, Google went down a lot, if you remember, as did many service providers. And today, we don't really hear of Google or Microsoft or Apple going down from a denial-of-service attack. That's not because they've gone away. The system has become much more robust and much more resilient to these attacks. Over time, we're seeing Bitcoin become more and more resilient to denial-of-service attacks and them having less effect. However, if you control Bitcoin on your wallet, if you have an application on your smartphone, the Bitcoin is not on the phone. What's on the phone is a public-private key pair that allows you to sign for transactions, and the Bitcoin is registered in the network. Now, this is the vulnerable part of the equation. So while you can't steal all the Bitcoin, you can attack individual control of Bitcoin on unsecured devices. And what this means is that Bitcoin is creating a much higher level requirement for device security and operating security. We're seeing a number of very interesting hardware devices designed with a single purpose in mind, only to store and sign Bitcoin transactions. And these devices present a very limited interface, store all the keys in hardware and only on the hardware, similar to how smart cards work. And those kinds of devices are much less susceptible to attacks. We haven't seen any really serious successful attacks against them. Interestingly enough, when you have programmable money, you can do completely new things with programmable security for Bitcoin. For example, a Bitcoin wallet, being a series of keys, can be copied. You can make multiple copies of it, and using multi-signature transactions, you can disperse the risk of ownership with those. Furthermore, because Bitcoin keys are simply long numbers, you can encode those in a form that can be printed on physical media. So one of the technologies we see used quite a lot in Bitcoin is paper wallets, where you print out the key material onto paper, and you physically store it in a secure location like a vault. So I carry 1% or 5% of my Bitcoin on my phone, and then 95 to 99% of my Bitcoin I have stored on physical media in secure physical locations. Just like you wouldn't walk around the street with your entire net worth in your wallet in cash, it is unsafe to keep your entire net worth in Bitcoins online and easily available. We're seeing a lot of attacks against users, Trojans, botnets, malicious software, social engineering attacks, and also if people choose to use Bitcoin in a way where they give other people control of their keys, essentially turning it into a bank custodial relationship, then the bank will run away with the money. And we've seen that happen with MTGOX and others. But the history of banks running away with your money is much older than Bitcoin. So if you replicate that environment inside Bitcoin, guess what happens? We have an expression in the United States which is possession is 9/10 of the law. If you have possession, you already have a significant legal advantage. Well, in Bitcoin, possession is 10/10 of the law. And if you have possession of the keys, it's your Bitcoin. And if you don't have possession of the keys, or you're not the only one with possession of the keys, it's not your Bitcoin anymore. It's a loan and a trust relationship with someone else. Great question. Thank you. Yes?
I have one more question. You just
Please.
mentioned the power banks may have. So one thing that bothers me a bit is if I use central bank money, I don't know who the bad guys are, but if I use bitcoins, I must assume that the inventor of the bitcoins, whom I do not know, holds a lot of bitcoins and hence is super rich. Is that correct? Is that assumption?
So the question was, if I use the banks, I know who the bad guys are, but with Bitcoin, I don't know. Or perhaps the owner or inventor of Bitcoin, who used the pseudonym Satoshi Nakamoto, for those of you who have heard of this story, is presumably very rich and therefore could have influence over Bitcoin. So first and most importantly, I think it's important to understand that the creator of Bitcoin has absolutely no control over the protocol, over the Bitcoin you control, over the way the system works. The source is open. It's been scrutinized and reviewed by thousands of security experts, and I can guarantee you that I have exactly the same amount of control over Bitcoin that Satoshi Nakamoto has, which is 0. However, there is the issue of economic control, and there is a matter of concentration of wealth in some of the early adopters of Bitcoin. Arguably, the difference is that these early adopters have a large amount of wealth, much of which has been invested into Bitcoin companies, but they have a large amount of wealth because they took a risk on an untested technology at a very early stage, rather than because their great-grandfather killed a lot of people. And I think that is a better way to distribute wealth in our society. But of course, there is that risk. And if you don't like it, there's a really simple solution. If you understand the power of the design pattern, you can always choose to use a currency designed on the same design pattern, which has a more egalitarian distribution of early adopters. You would be taking a different form of risk if you went into that currency than into Bitcoin, and therefore you would be rewarded less for that risk than if you were in the early days of Bitcoin. And by the way, I am not a Bitcoin millionaire. I am at best a Bitcoin hundredaire. So I'm not saying this because of my own personal self-interest. Yes, sir.
I'm a software developer, so hearing about BitChain, is that right? BitChain?
Blockchain?
Blockchain, sorry.
Yes.
Turing complete, that opened up in my mind of a whole mess of attacks and bugs. I can bug your wallet by sending you money or the whole network by sending a transaction into the network. Is that right?
So that is a very interesting, and there's a philosophical debate and also a technical debate going on. So the question was, as a software developer, when I hear Turing complete, that worries me. It opens a whole mess of potential attacks where I could send something to your wallet and, using the nature of Turing complete, overwhelm your ability to do it, perhaps even find some vulnerabilities with that, if I'm paraphrasing a bit. Certainly, Turing complete introduces a whole lot of things. Bitcoin was designed to not be Turing complete on purpose. So the scripting language is limited. In fact, after the original deployment of Bitcoin, the first round of changes were to remove about 15 opcodes to make it even less flexible in order to ensure a much higher level of security. And of course, it's battle tested. It's survived 6 years of attempts to attack it. Systems that are Turing complete, like Ethereum, are trying a different approach. It's a different balance between flexibility and security. They're trying to strike a different compromise or balance between those two. In the case of Ethereum, one of the things that happens is if you encode a contract, that contract will be evaluated and will have a limit on how much processing power it can consume. And that limit is paid for through Ether, which is the currency. So essentially, you pay for the computation that the network will have to do to evaluate your contract. And as the network is evaluating your contract, if your contract exceeds the amount that it states it should use and how much you have paid for, it will stop execution of your contract. So by imposing a monetary restriction on resources through a market-based mechanism, the Turing complete system is constrained in its total execution time. You don't know when it will terminate, but you do know when you will terminate it, which is when it runs out of money. That's an excellent question. Thank you. Anybody else want to ask a question? One more question, last one. Yes.
Talking about decentralized way of dealing with money, which is a really nice idea. From another perspective, it's a very dangerous idea. So what is your...
Dangerous to whom?
Because it's not wanted by certain people, because control is something very nice thing to have and very powerful.
So great question. This is a question I get all the time. So the idea of a decentralized money that no one can control is a very dangerous idea because perhaps we want control over money and because some people should not use money. Well, we've tried that model. We've given control over money to banks and governments, and they may say that they have used that control to protect us, but it turns out that some of the biggest money launderers and financiers of drug lords and warlords around the world happen to have banking licenses and also manage to do so without any repercussions in law. So I would argue that that control system has not, in fact, succeeded in that way. The truth is that drug dealers and terrorists use US dollars, often given to them directly by our own intelligence agencies or with full knowledge of our own intelligence agencies. Rather, we live in a world where 2.5 billion people have no access to banking, and another 4 billion people have such limited access to banking because of geopolitics. And we now have the technology to bring 6 billion people into the world economy. And I can tell you for sure what 6 billion people will do with their money. They will buy food and shelter and clean water and healthcare. Just like the internet originally was pictured as a den of thieves, pornographers, and terrorists. And in fact, it was, until the rest of us used it. And once the rest of us used it, the internet became a den of cat videos and lame comments on Twitter and a waste of time for everyone, but also a source of great economic productivity and pleasure and many other things, most importantly, freedom. Bitcoin does worry some people, but they're not worried that criminals and terrorists will use it. They are terrified that all of the rest of us will use it instead. Thank you.